Hey students, this video is about chemical bonding in chapter 10, and we discuss the first preliminary concepts to help us better understand how molecules come together and have certain shapes. So we must talk about Lewis theory. Now, Lewis theory is pretty straightforward and it's simple to apply. It centers basically on how many valence electrons are in atoms. And the reason why the focus is valence electrons is valence electrons are the ones involved in bonds. So we know that oxygen's in group 6A. So oxygen has 6 valence electrons. We see this in the electron configuration and in the abbreviated configuration as well. We know that oxygen is in the second period in the P block, in the fourth position of the P block. But another way of looking at it is it's in group 6A. Why is that? Its valence shell, the second orbital, is 2s2, 2p4. So that's 6 valence electrons. We don't really look at the 1s2 because that's in a core electron shell and it's not involved in bonding. So it has 6 valence electrons. So what do? We draw 6 dots. This concept's really easy to apply. We can look at any element and basically we're going to draw its elemental symbol and the dots to represent the number of valence electrons. How do we know the number of valence electrons? We look at the group number. So 1A is going to have 1, 2A is going to have 2, and we'll go all the way down to the 8A. So the Lewis dot symbols are pretty much this. Lithium has 1 valence electrons, a 2s1, so it's got 1 dot. Beryllium has 2 valence electrons, a 2s2, 2 dots. Boron has 3 valence electrons, 2s2, 2p1, because this is my p block portion. Carbon has 4 valence electron, group 4a, so 4 dots. That's a 2s2, 2p2, and so on. So Lewis realized that the noble gases all had 8 valence electrons, except helium, which has 2. But the noble gases are extremely stable. So as a result, he reasoned that 8 valence electrons, or an octet, must lead to stability and results in elements being unreactive. So all elements are striving to have this octet. They're willing to lose electrons, gain electrons, or share them and to achieve this octet. So we use the terms octet and duets for elements like hydrogen and helium that want 2 electrons. So I hope this makes sense. I hope you understand the basic concepts of drawing Lewis dot symbols. So for example, sodium's dot symbol would be Na with 1 dot. And why is that? It's in group 1A. Its configuration is a 1s2, 2s2, 2p6, 3s1. I'm only concerned with the valence shell, and it has 1 valence electron. That's why it's in group 1A, and it has 1 dot. So thanks for tuning in, and I'm going to make another video. All right.